We're going to show how different VMware data products work together to create a scalable streaming application that can handle real-time data using Spring Boot framework. We will demo an interactive app we call Twitter Workload, which pulls tweets from Twitter by the emergency hashtag. Basically, every time anyone tweets anything with the hashtag emergency, we are capturing those tweets. The hashtag is configurable and can be changed to anything else. After a tweet is pulled, we break it into words and do some lexical analysis. And finally, we draw all words in our app as a word cloud, meaning the more frequent is the word, the larger it appears. You can see here the RT word is frequent for some reason, and there are also words like emergency, contribute, help, and some other words. Let me show you the architecture. On the top left, we have the Twitter we connect to with Twitter API version 2. You need a Twitter developer account for this to get the API key, which I have. Twitter microservice on the left-hand side pulls tweets by the hashtag every 15 seconds. And this can be changed to any other frequency if we want it. Twitter microservice publishes all tweets to two targets within the same RabbitMQ cluster. So one is RabbitMQ, and it's used for real-time notifications. And the second is RabbitMQ Stream, which is used for full history. Now we have a second microservice we called a Twitter workload, which scales horizontally so that it can have multiple replicas to handle larger traffic on multiple machines and provide high availability, and each replica has a built-in web server so that we can open a browser and see the UI like you see here right now. This microservice consumes tweets from RabbitMQ Stream and saves them into a low latency cache called RabbitMQ GemFire, providing fast real-time access to data. Most importantly, the Twitter workload microservice has a very important feature, the time offset, which determines from which point in time we want to analyze the captured tweets. So now we see a demo with live data within last hour. Let's quickly try to show you the full history. Because we have full history here in the stream, and we can do the time travel. So to go back in time, we need to stop the workload microservice for a second. We need to clear the cache, clear GemFire. We need to change our history offset to something, let's say 1st of January, which is our kind of beginning of time. And we need to restart our Twitter workload microservice. So while it's restarting, let's quickly mention that each backend product we have, the GemFire and RabbitMQ, is run on Kubernetes, which ensures high availability and resilience. If I can quickly flip to our Kubernetes, that is our pods. So we have the Tanzu GemFire namespace running the GemFire, and we have the RabbitMQ system namespace running RabbitMQ with multiple pods, highly available. Now let's get back to our microservice. It's restarted, and we can see many more words because now we're looking into our full history since beginning of time. And we can quickly look into our RabbitMQ stream. We've got about 700 tweets all in all, and they are all displayed in here. Now this type of feature is very useful. Since we have full history, we can replay those events as many times as we need. We can go back in time to any point in time we need, doing the time travel. This can have application in the industry, such as regression testing or surveillance systems. Now let's quickly mention the code. It's Java, and we use Spring Boot framework. Spring Boot is a framework to develop cloud-first microservices which are scalable, secure out of the box, and event-driven. The framework is declarative, is using annotations, and requires minimal code to be written, so that the developer experience is fast and straightforward. For example, what we're looking here right now is the cache service, and the caching is done via those two annotations, cacheable and cache put, on two respective Java methods. This is highly abstract. This is very simple. This can work with multiple caches. So we have the project structure on our left. We have configuration. We have controllers. We have model and services. So controllers are the entry point for our HTTP requests. Each controller is lean and stateless. Controllers take all services which are also stateless, and this is where the business logic is. Besides, under utils, we've got a collection of static functions serving different purposes, such as lexical analysis and Twitter-related stuff. Because the application is stateless, which is one of 12-factor app principles, our Twitter workload can scale to hundreds of replicas. Now we are at the end of our presentation, and I hope you enjoyed it.